So for 6.3a, we're doing part A of 6.3 today and part B on Friday. We're going to be solving radical equations with square roots and cube roots and rational exponents. So remember, that is like a fraction. So if I have x to the 1/2. So a rational exponent means that there's a fraction in my exponent. So how do I solve these? There are steps involved. First step is you want to isolate the exponent or get it by itself on one side of the equation. It doesn't matter which side, but you do need to get the exponent term all by itself. Step 2, you are going to root each side of the equation by the same index to eliminate the exponent. So if you are squaring something, you take the square root. If we are cubing something, you take the cube root. So all depends on what the exponent is. Then we're going to be able to solve the equation. And for these problems, you always want to make sure that you check your answer. So example 1, we have 4x to the 5th equals 128. My exponent term is the x to the 5th part, so it's not by itself yet. In order to get it by itself, I'm going to divide both sides by 4. So that's going to give me x to the 5th equals positive 32. Now my exponent is 5, so that means in order to cancel out the exponent of 5, I have to take the 5th root of both sides. Now taking the 5th root is different than taking the square root because my index is odd. So remember, if my index is odd, I am allowed to have negatives on the inside, which means there are no imaginary numbers, and because the inside is positive, my answer will be positive. So I don't have to worry about plus or minus when the index is odd. So the 5th root of x to the 5th is going to give me x. And then I need to figure out how 32 breaks down. You should have this one memorized. The 5th root of 32 can be written as 2 to the 5th. So that's going to give me an answer of x equals 2. To check this one, I would take x equals 2 and plug it back in. So that would be 4 times 2 to the 5th, and I want that to equal 128. And then order of operations says I have to do exponents first. So 2 to the 5th gives me 32, and 4 times 32 gives me 128, which is what I wanted. Example 2, we have x minus 2 to the 3rd power equals negative 14. In this case, my exponent term is by itself because x minus 2 is all in parentheses. So I'm going to take the cube root of both sides. So that's going to give me x minus 2 equals the cube root of negative 14. And because I have a cube root, I am allowed to have a negative on the inside. So I want to figure out if 14 breaks down at all. 14 is 7 and 2, and there's no groups of 3 in there. So we're going to leave the cube root of negative 14 inside my exponent for right now. The only thing that we do want to make sure we do is pull that negative out, because this is going to end up being an addition problem. So this is x minus 2 equals negative cube root of 14. And we want to pull the negative out because since my index is odd, I know that my answer has to be negative. So we can just go ahead and pull that out right now. And then to solve for x, I add 2 to both sides. So I get x equals 2 minus the cube root of 14. Yeah. Example 3, we have x plus 5 to the 4th power equals 16. My exponent term is already by itself, so I'm going to take the 4th root of both sides. So that gives me x plus 5 equals the 4th root of 16. Now because my index is even this time, we do have to worry about plus or minus, because if I multiply a negative number 4 times, that could still give me a positive number on the inside. So let's write that rule. If the index is even, the answer is plus or minus. So only if the index is even do you have to still worry about your answer being plus or minus. So this is actually going to be plus or minus, and then 16 breaks down to 4 and 4, and each of those break down to 2 and 2. So this is plus or minus 2 to the fourth root of 2 to the 4th power. So we get x plus 5 equals plus or minus 2. Now, I want to solve for x here, so let's break that up into 2 scenarios. I have x plus 5 equals 2, and x plus 5 equals negative 2. Subtract 5 from both sides, and I get x equals negative 3 and negative 7. So when your index is even, I'm going to put a star next to that, you need to make sure that you write your answer as plus or minus, because we could plug in negative 3 for x or negative 7 for x, and it would still give us a true statement. So that's solving equations that have exponents in them. What if I have an equation that's in radical form? So for solving radical equations, there's also 4 steps. First, I want to isolate the radical on one side of the equation, just like before, so I want to get it by itself. And then this is the important part. I want to raise each side of the equation by the same exponent to eliminate the radical. So if I'm taking the square root, I'm going to square both sides. If I'm taking the cube root, I'm going to raise both sides to the 3rd power. And that's going to get the radical. If we have a fraction in the exponent, we want to raise each side to the same power to get rid of the rational exponent. So we're going to try and get rid of the rational exponent by raising each side to the same power. Then we will be able to solve, and we always want to make sure to check our answers. Example 4. We have the square root of 5x minus 9 equals 11. I want to make sure that my square root is by itself. And it is. So what I'm going to do is I'm going to raise each power to the raise each side to the second power, because my index of a square root is 2. You just don't have to write it. So that power of 2 is going to cancel out the square root. So it's going to give me 5x minus 9 equals 11 squared gives me 121. Now solving should be pretty easy since we've been doing it all year long. You add 9 to both sides to get 5x equals 130 and divide both sides by 5. So you get x equals 26. To check my answer, I would plug 26 back in for x. So let's just do a quick check of this one. I'm taking the square root of 5 times 26 minus 9, and I want that to equal 11. Five times 26, so that is the square root of 130 minus 9, and I want it to equal 11. And the 130 minus 9 gives me the square root of 121, and the square root of 121 is 11. So that's what we wanted, so we got the correct answer. Now, it does not have to be plus or minus over here because the square root is already written in. I am not the one physically drawing the square root, so we can go ahead and leave our answer as the positive option. Example 5, we have the cube root of x minus 5 plus 1 equals negative 1. So what we want to do here is we want to get the cube root by itself. So I need to subtract 1 from both sides. That's going to give me the cube root of x minus 5 equals negative 2. And now the cube root is by itself. So I'm going to raise each side to the power of 3. So that's going to give me x minus 5 equals negative 8. Add 5 to both sides, and I get x equals negative 3. Example 6. I have 2 times the cube root of x minus 3. My cube root is not by itself yet. 2 is being multiplied, so I have to divide both sides by 2. Those cancel, and I get the cube root of x minus 3 equals 2. I have the cube root by itself, so I'm going to raise each side to the power of 3. So that's going to give me x minus 3 equals 2 to the third, which is 8. Add 3 to both sides, so x equals positive 11. Example 7. So things are about to get a little bit more complicated here. We have 7x to the 3 over 5 equals 56. So our goal here is we want to get the power term by itself, which it's not right now. So I first need to divide both sides by 7 to cancel out those 7s. So that's going to give me x to the 3/5 equals 56 divided by 7 gives me 8. Now, what I want to do here is I'm trying to get rid of that exponent that's a fraction. So first let's get rid of the denominator. Our denominator of 5 is the same as saying the 5th root. So that means I want to raise each side to the 5th power. Because watch what happens. This is the same as 5 over 1. And 3 over 5 times 5 over 1, those 5's cancel out. So I am left with x to the third equals 8 to the fifth. Do not multiply out 8 to the fifth yet, because we still have to get rid of that power of 3 by taking the cube root. The cube root of x to the third gives me x equals, and I'm not exactly sure how far I can take the cube root of 8 to the fifth, because I can break 8 up even more. 8 is the same as 2 to the third. So this is the same as saying cube root of 2 to the third to the fifth power. So that's x equals the cube root. 2 to the third to the fifth power is 2 to the 15th power. And now I can look for groups of 3 here. The cube root of 2 to the 15th, 15 divided by 3 actually gives me 5. So the answer is going to be 2 to the 5th power. But we can do that. 2 to the 5th power comes out to 32. Let's try it again. So example 8. I have 3x plus 4 to the power of 2/3. So I always want to get rid of the denominator first. So let's write that note off to the side. Get rid of denominator first. Okay, so we want to get rid of the denominator first. So to get rid of that denominator, we want to raise each side to the third power, because the 3 and the 3 are going to cancel each other out. Now before we rewrite this, how could we rewrite 16 to the third power and as small as we can? 16 is 4 and 4, and each of those 4's are 2 and 2. So this is the same as 3x plus 4 squared, because those 3's canceled, equals 2 to the 4th to the third power. So this is 3x plus 4 squared equals 2 to the 12th. And now I can take the square root. So those are going to cancel, so I'm going to get 3x plus 4 equals, now remember, when I'm the one taking the square root, my answer has to be plus or minus. And how many pairs can I pull out of 2 to the 12th? That's going to leave me with 2 to the 6th. Now I'm not done solving. 2 to the 6th is equal to 64. So this is 3x plus 4 equals plus or minus 64. And we have two scenarios again. So let's set each one equal to the positive and equal to the negative. So that's going to give me 3x plus 4 equals 64. Subtract 4 from both sides. So 3x equals 60. And divide both sides by 3 to get x equals 20. And then set it equal to the negative. So 3x plus 4 equals negative 64. Subtract 4 to get 3x equals negative 68. And divide by 3. So we actually end up getting x equals 20 and negative 68 over 3. Example 9. We have the square root of 2x plus 5 equals the square root of x plus 7. I want to get rid of that square root, so I'm going to raise both sides to the second power. And this is actually going to help me out because it's going to cancel out the square root on both sides. So that's going to give me 2x plus 5 equals x plus 7. This is an Algebra 1 problem, so we want to get all x's to one side. So let's subtract x from both sides. 2x minus x gives me x plus 5 equals 7. Subtract 5 and I get x equals 2. Example 10. We have x minus 2 equals the square root of x plus 10. So my square root term is by itself, so I want to get rid of it. Even though it's on the other side, we're still going to do the same thing. So we raise both sides to the second power. So this is actually x minus 2 squared, which is not x squared minus 4. Remember, we can't just distribute this because of the subtraction between. So we need to expand it. X minus 2 times x minus 2 equals, those square root canceled, so that is x plus 10. Now, x minus 2 times x minus 2, you can use FOIL or box method. X times x gives me x squared. X times negative 2 is minus 2x. Negative 2 times x is minus 2x. And negative 2 times negative 2 is plus 4 equals x plus 10. Combine like terms, so that gives me x squared minus 4x plus 4 equals x plus 10. And now we want to solve. This looks like a factoring problem. So let's subtract x and subtract 10 from both sides. So that's going to give me x squared minus 5x minus 6 equals 0. And we can use diamond method on this. Two numbers that multiply to negative 6 and add up to negative 5 are x minus 6 and x plus 1. So we set each one equal to 0. And we get x equals 6 and x equals negative 1. Now for this problem, let's do a quick mental check. If I plug 6 into the original problem, x minus 2, or 6 minus 2, is going to give me 4. 6 plus 10 gives me 16, and the square root of that is 4, so we're good there. If I plug in negative 1, that's going to be negative 1, let me write this down, negative 1 minus 2, and we want that to equal the square root of negative 1 plus 10. So let's double check. Negative 1 minus 2 gives me negative 3, and negative 1 plus 10 gives me negative 9. Now wait a second. I have a square root with a negative on the inside. That's not allowed anymore because we do not have imaginary numbers anymore. We're taking them away. So this is not a possibility. So I actually only have one answer, and that is x equals 6. So it's very important for you on these problems to plug your answer back in and double check, because I guarantee on the test there will be at least one where one of your answers will not work. So you need to double check your answers to make sure that both of them make sense. So in this case, if we plugged in 6, it worked. But if we plugged in negative 1, we did not get a true statement. So we have to eliminate negative 1 as an answer choice. And that is using solving when we have square roots and radicals. So your homework for tonight is going to be from the textbook, page 418, and also page 456. So make sure that you are aware of that, and then you guys now have a quiz.